Phascan 2, Application Video. Phased array operation, sector scan weld inspection. Select Clear Settings. Main menu. Setting. System. Reset. Start setting parameters. Click Wizard. Select Display Mode ASC. Click Start Wizard. Set workpiece structure. Set workpiece material. Set weld parameters. Set weld parameters according to illustration and actual weld. Click to next step. Set probe. According to the mark of probe. Set wedge. According to the mark of wedge. Click Next. Set focus law. Set mode to sector scan. In second wave scan, set focus depth to 1.52 times of the plate thickness. Set the position of probe according to the illustration. Step offset. Make second wave fully cover the weld. The first wave covers the weld root. Click Next. In the case of encoder, select Scan to encoder. Adjust scan speed to maximum, can manually enter a larger value. When exceed the maximum, the instrument automatically selects current acceptable maximum. Set the resolution of encoder. Sets the range to be scanned. Then need to calibrate. Select test blocks of the same material as the workpiece for calibration. If the velocity is known, it cannot be calibrated. Generally select CSKIA test block for velocity calibration. Other calibration test blocks may also be selected according to the standard. Place the probe near circle center of the test block. Click Velocity Calibration button. Enter the calibration menu. According to the actual radius of test block. Set to radius. Double-click the gate, move the gate, or click Gate Starting Point, use Shuttle to move the gate. Then use the gate, make the first radius wave in the gate. Move the probe around to find the highest wave. After find the maximum wave, click and read position 1. Keep the probe still, move the gate to cover the second wave, click and read position 2. Click Calibration, velocity will be displayed after finish the calibration. If unreasonable, recalibrate. If velocity is reasonable, click OK, finish velocity calibration. Next wedge calibration, to correct the wedge parameters. Some self-focusing probes and small curvature arc wedges, when can use this calibration, can use delay calibration. After wedge calibration, delay calibration can be not done. Clean the wedge surface first. Click Wedge menu to enter the wedge calibration. We can see the probe surface wave. Adjust the gate start point, width and height to cover the wave. Click VPA to adjust parameters, check whether each wave passes through the gate. Click Calibration, calibration completed. Click OK. Generally delay calibration is performed with small holes. We select 1.5 mm depth of CSKIA test block, thickness 15 mm hole for calibration. Put couplant on surface of test block, place the probe. Click Delay Calibration to enter the Delay Calibration menu. Adjust hole depth according to actual conditions. Adjust gate height to about 10%. Adjust the gate. Gate cover the small hole wave. Then move the probe left and right. The whole echo is recorded at each angle. Then click Calibration. Delay calibration completed. Click OK. Then go to Sensitivity and TCG calibration. Generally, if need TCG calibration, then done. T needs sensitivity calibration. Method of sensitivity calibration. Click Sensitivity calibration to enter sensitivity calibration menu. When make sensitivity calibration, select the hole to be calibrated. After the probe is placed, check small hole echo from sector scan area. Use the gate to cover the whole echo. Then move probe left and right. Echo collected at each angle. If the envelope is miscellaneous, move again. Click to clear envelope. Remove. Move complete. Click calibration. Then move the probe and observe echo. If the condition is not good, click calibration again and do the second calibration. Click clear envelope to verify again. After verification, click OK to complete sensitivity calibration. Then go to TCG calibration. Generally, when use the secondary wave inspection, the whole depth range. The minimum depth shall be smaller than the plate thickness. The maximum depth is more than twice the plate thickness. First select 15 mm depth hole. Place the probe above the hole. Move the probe and find the echo in the sector scan area. Use the gate. Cover the echo of hole. Adjust gain. Keep the maximum echo height of the first hole between 40% and 60%. Click clear envelope. Move probe left and right. Record echo at each angle. After finish envelope, click add point. Remove the probe and verify the point. If it is not reasonable, click continue to calibrate and recalibrate. Move the probe again, observe the condition after recalibrating. As you can see, this wave height is reasonable. Click OK, make the next point. Place the probe above the next point and move the probe. Find the point in sector area. Use the gate to cover the point. Then move the probe left and right, to record the maximum echo of each angle. Click add point. Then verify the point. The verification passes. Click OK. The verification not pass. Click recalibrating. Then make the next point. Place the probe above the new point. Move the probe. Find the hole echo in the sector scan area. Use the gate. Cover the echo of the hole. Note, when all angle calibration, the hole echo needs to be located above the triangle area. If below the area, need to adjust the range. Clear envelope and move probe. Record maximum echo of each angle. Click add point and verify the point. Verified. Click OK. In practice, the maximum hole depth needs to be below double plate thickness. This time, because of the test block reasons, will not be made. After finish TCG curve, click OK. Complete TCG calibration. Click OK to exit the calibration menu. Click OK to exit the wizard. Next to set the game. Select UT settings. Advanced. Click DB-Ref. Open reference game. According to related inspection standard, improve different game, set different quantitative lines. I follow 47103 standard. The quantitative line is phi 2 minus 12 dB. We add 6 dB. Quantitative line position is 40%. Add gain 6 dB. According to true condition, add coupling compensation. Add coupling compensation 4 dB in this time. Next set the standard curve. Click main menu. Gate curves. Curves. Select mode curve. Curve quantity input 4. Set the curve height as needed. Set the corresponding height. The standard height is 80%. The quantitative line SL height in this state is 40%, so input deviation 6 dB. Choose measure value 8 dB SL, means flow equivalent. Next set the gate. Adjust start point and width of gate. Cover the root of first wave and full of second wave. Select the gate from the main menu. Press shortcut key of gate directly. Click gate. S start point. Set related parameters. Choose a gate. Adjust gate S starting point. Cover the root of the first wave. Adjust the gate width. Cover full second wave. Raise gate height to 20%. Then place scanner on the workpiece. Place probe according to step offset in instrument. Step offset is the distance between the probe front and the weld center. After place the probe, move the scanner and place it at the start point. There is blind zone at start point in scanner, different blind zone on both sides. Measure this blind zone then input into the instrument. Measure from the center of probe to the 0 point. Side blind zone 25 mm was measured. In main menus, select scan. Encoder. Click origin set encoder start point. Long press can jump out of input keyboard, set to 25. Click start, record data start from 25 mm. Then push the encoder to see the direction of data recorded. If the data is recorded forward, the direction is correct. If data is recorded backward, adjust the polarity in encoder menu. Then if need, set coupling monitoring. Coupling monitoring under display menu. Select main menu. Display. Selection. Coupling. Set coupling. On. Choose a useless display value. Set it to coupling monitoring wave height CP%. Then adjust the coupling offset gain. Set the echo of coupled monitoring to about 160%. When the wave height is below 80% will trigger coupled monitoring alarm. Configuration completed. Then save configuration. Select file. Select save mode to set. Change the file name. Click save. Then start scan. Place scan device at the start point. Click to start. Move scan device, start scan. Click freeze button after finish data scan. Select the file from the main menu. Set the save mode to data. Change the file name of data. Click save. Finish data save. If need to analyze data, click the open button under the file menu. Select related data to open. After open the data, select the cursor to on under the measurement menu. Pull the data scan axis to see details. In measuring state, need to see some parameters. A percent, echo height. dA, floor depth. PA, distance between probe front and floor. ADBSL, floor equivalent. S, R, and S, M, means to positions cursor in Phascan. To indicate floor. S start point and end point. D, MR, the difference between two horizontal cursors in S display, indicate floor height. S, M, cursor. S, R, cursor. D, R, and D, M, cursor. Datascan access. After mark floors according to related standards, use S, R, and S, M, to mark floor positions. Then move scan data axis to the position of maximal floor. Find the upper and lower points of the floor in S display. Double-click display position, cursor will automatically move to the position. D cursor is used to mark the upper and lower points of floor. Click to drag VPA line. In measurement menu, fine-tune cursor in each display view. After mark floors. Open record images under floor report of measurement menu. Click add floors, then analyze other floors. Click table to check currently saved floors. Analyzed floors can be selected to delete. Preview the current analysis report under the File. Report menu. Select to save related reports.